Okay, hi everyone. So I want to talk about finding vertical asymptotes for rational functions. Okay, so we talked about earlier the parent function of reciprocal functions was 1 over x. And so whenever your denominator, alright, x, is equal to 0, that's when it's undefined. Okay, so that's when it is undefined. Alright, so basically that means whenever your denominator, so right here, well, I guess I'm repeating it. When that's equal to 0, then you have your vertical asymptote, because that's where it's undefined. So this right here, that implies that that is your vertical asymptote. Right? That was for the parent function. Now, what if you have a function like, well, here it is, a of x over b of x. You have an expression, a of x, and then you have, or actually a function more say, a of x over b of x. What is the vertical asymptote here? What are we going to do? Well, you will look at your denominator again. The key thing is all in that denominator. And set it equal to 0. So you will set b of x equal to 0. And solve. And you would get your vertical asymptote line. Okay? Okay, so moving along, let's go ahead and talk about an example. Alright, so let's see it in context. Let's say you have 1 over x squared minus 1. Okay, your denominator is what? It's x squared minus 1. So x squared minus 1, set that equal to 0 and solve. But before we solve, you can either use, whatever squaring techniques or that you like completing the square factoring you can use. But I will go ahead and factor this one. So this one is now what, x plus 1 times x minus 1 equal to 0. Set each one equal to 0. Alright, solve. And so you have x is equal to negative 1. And then you also have, so if I do plus 1 on both sides, on this side, I get x is equal to positive 1. So in this case, we have two vertical asymptotes, one at x equals negative 1 and another at x equals 1, for our rational function, which is 1 over x squared minus 1.